Now, suppose we have two parallel plates dipped in a liquid. So, you see this is one plate and this is another plate. They are very close. So, this is the adjacent free layer. Now, what we do? We find that if they are very close, the liquid rises to a certain height. So, you see the liquid rises to a certain height above this free layer, free surface. This is the rise of liquid in two parallel plates. So, you see these are parallel plates and you see these are plates, rectangular plates, and the liquid rises like this. So, it assumes a cylindrical meniscus. So, this is a cylindrical meniscus. You can see this is a cylindrical meniscus. So, in order to know what is the capillary rise, we can use many methods, but take point 1, point 2 and 3. Apply excess pressure method. So, I am applying first method, that is excess pressure method. Excess pressure method. So, you see applying excess pressure over for cylindrical surface, excess pressure tells that S 1 by R1 plus 1 by R2. So, for our present case 1 by R is there and this is infinity, so plus 1 by infinity. S times 1 by R. Now, suppose I assume that this thickness is D, the distance between the plates is D, then what will happen? Then you see here, these are the two plates and this is the distance between them and this is the meniscus. So, you see this is R and this angle is theta. So, this is 90. So, this angle is theta. So, we have cos theta as D by 2R. So, we have to put this R here. So, we have P is equal to S by R. Now, here this R is the radius of curvature. So, this is S by R, that S by R means R 1 by R is here 2 cos theta by D. Thus, we have now P excess pressure is P1 minus P2 as 2S cos theta by D, one relation. Also, P3 is equal to P2 plus H rho G, where H is the rise of liquid in between the plates and this itself is P naught, P3 is P naught. You see P1 is also P naught. So, this is P2 plus H rho G, this is second term. So, let us put this P2 here. So, from 1 and 2 we get P1, P1 is P1 minus P2, P2 means we have P naught minus, so it will become H rho G becomes 2S cos theta by D. Now, P1 and P naught cancels because P1 is also free in air. So, we have now H as 2S cos theta by rho GD if theta is the contact angle. If it is water, theta is 0 for water and cos theta will be 1. Now, come to the second method, the force method. Second method, that is force method, equilibrium of force we are going to see. Now, this is our capillary, so not capillary, two plates and this is our rise of a liquid in this H. So, you can see this is, suppose this L is here. So, you see here this angle is contact angle is theta. So, you have actually a force 2 times S, this S into suppose this length is L. So, SL force is there, SL force 2 times in this direction. So, we want its vertical component. So, it becomes cos theta. So, this is F vertical that has to balance the weight, So this is the vertical force. So we have 2SL cos theta is equal to weight. Now what is weight? So weight means the weight of this liquid. So density into D, D is this into H, this is the area, D into H is area, area into mass, this is weight mg, and so I want only height h. So this is 2s, and one thing L is also there, D into H, D into L is the area, so this L cancels, 2s cos theta by rho dg. So this is the expression for the rise of liquid in between the two plates which are closely spaced and placed inside a liquid.